Thank you for the introduction. So, one moment. So, nice that I had so short introduction and a stage for me now. Today I would like to present the results which we managed to receive with my colleagues. And we made a study on the traffic modeling, and we considered, or we tried to consider, the weather properties, and we made that study on as a case study of Ülemiste City. So shortly about myself, so I'm doing the research for more than 10 years already, and my last years I'm focusing on different machine learning approaches and to apply them on various technological and engineering problems. So now let's turn back to the topic. And I suppose that you all know that Ülemiste City is aiming to become a smart city, and therefore it established 5 main goals. And those are related to smart economy, smart knowledge, community services, and of course, environment. This is very hot topic at the moment. So, and within the environmental panel, there is mobility, and the mobility is related to all traffic modeling. And it has its own strategic objectives. And those are increase the number of the non-motorized vehicles within the Ülemiste City area, to decrease the number of the cars and the vans that are driving within the center of the Ülemiste City. So to improve the accessibility to Ülemiste City using the public transportation, and of course, hot topic, to make the parking more advanced and increase the vehicle sharing services. So these objectives can be solved by the support of the data. And first of all, we need to collect the data. Then as a next step, we analyze the data. And based on these analysis results, we can support the decisions. So on the traffic management, for instance. So we had posed ourselves the following questions. So we first wanted to be aware what kind of the data sets can be suitable for the flow modeling. The next question was to be aware of the machine learning methods that we can apply to model the traffic flows. The next was how the weather properties and what kind of special weather properties are relevant, for instance, for the cars, for the vans, or for the light traffic. And as a last is how this machine learning the application of the machine learning methods and the results received can be used in concrete use cases. So everything starts with the data, and of course we started with the data as well. So on the right-hand side you can see location of the cameras, and this is this is the map of the Ülemiste City. And there are 4 road intersections that are allowing to income or outgo from the city. And in this study, what I'm presenting, we considered only 1 road intersection. This is the Suur-Sõjamäe-Lõõtsa. And how did we get the data? So this traffic data was generated by the external machine learning object detection model, which actually is applied on the live video streams that are running in the cameras. So this algorithm detects the objects, it puts the labels, cars, vans, etc., and it saves those counts within some certain time period in the time series database. So this way, the traffic data was generated. So here I would like to introduce the basic structure of these so-called input features, what we used in the modeling. So as I mentioned, the traffic data was accounts with the time steps, and to use it in machine learning, we had to define it as a supervised learning problem. So for this, there is a so-called sliding window method, and the width of that sliding window is equal to the number of the previous time steps. So this way, this historical traffic data is generated. So we used sliding window width that was equal to the 27 data points, and that was equivalent to the 1 day. So our first approach was a basic, naive model when we considered the present-day vehicle counts, and we forecasted the same amount of the vehicles for the next day. So the next, we tested three machine learning algorithms. Those were linear regression with a Huber loss, and extreme gradient boosting. So the basis machine learning model, the input features were only historical traffic data. So further, we tried to combine the historical traffic counts with the historical weather. So, and we tested each weather property, and these weather properties were weather phenomena, it's categorical data, wind speed, numerical data, air temperature, and we tested each of these weather properties with the historical traffic counts, and also we had a model which combined two weather properties, wind speed and air temperature and weather phenomena with the historical traffic counts. So, and as a conclusion, what findings? So we concluded that our basic model, that was a naive model, it worked also quite well. The prediction for the next day did not exceed the error of 10%, which is quite good for this simple approach. But machine learning methods, they improved the accuracy of the basic model by 26–29% in average. So what about the weather? So the weather didn't improve significantly the accuracy of the basis machine learning methods, but those were, we considered in this study only the cars and the vans. So maybe for the light traffic, of course for the light traffic the effect can be different. So then XGBoost algorithm, it demonstrated the effect of weather phenomena, exactly snow or rain for incoming cars. And linear regression and Huber loss, they demonstrated the effect of the weather, but only for the outgoing vans. So we made the feature importance evaluation, and I think that this data is quite important for the advanced management of the parking. So we know important, let's say, this relevant daytime hours for the cars and the vans. So thank you for the attention, and in case you have questions, I'm glad to answer them.
Thank you very much. Do you have questions, ladies and gentlemen? There is a question over here. Can we provide the lady with a microphone? Here you do. Here you go.
Yeah, thank you very much for an interesting presentation. I saw the visuals and I'm familiar with those. So my question is, are you collaborating with FIMA or?
Yes, absolutely. So exactly those traffic counts, this external machine learning object detection algorithm is provided by the company called FIMA.
Excellent. Any more questions, ladies and gentlemen? We have a question from the back row. Go ahead.
Yeah, it's again me.
Good to see you.
My question is, do you have also cooperation with insurance companies? They are very interested in these results because they are considering usage-based insurance fees.
Thank you for the nice advice. It's a good idea. No, we are not doing that, but I would like to thank you. This is a good idea.
Any more questions? Mait has one. Can we provide him with a microphone?
Yeah, thank you very much for your interesting and vivid presentations and a lot of facts. So what would be your recommendations to get, let's say, Ülemiste City, that the amount of cars what we have here could be diminished by half? So what criteria must be fulfilled? So what would be your recommendations?
Let's move Estonia to Spain, perhaps.
Do we have to have extreme weather conditions to achieve that, or anything else? So what would be your recommendations?
Yeah, thank you for the question. My recommendation would be to manage or to make the public transportation, how to say, more sure. I mean that to make this effect of the cars less and to provide more supportive public transportation to this place, Ülemiste City. And maybe one more advice is to highlight more the vehicles sharing services.
Or give free umbrellas to all people visiting Ülemiste.
Maybe.
One more thing, if there's no more questions from the audience. I mean, you hinted to that, but how has your research contributed improving air quality in the city, and do you see potential for it?
You know, this air quality is very relevant with a combination of these statistical results, because if you know the counts and the distribution of the cars and the vans within the daytime hours, you can calculate the CO2 emission from the transportation. So it's a direct relation. So you are like controlling or you are tracking your CO2 emission from the transportation in this area.
Thank you very much, Marika. This is all we have time for.
Yeah,
Applause, ladies and gentlemen.